quite important, whatever use we'll make of the soil, and we're going to talk about those in a little more detail. And before I say anything else, let me just point out, I'm sure, hopefully, some of you folks are familiar with these, but soil surveys gives us a very basic understanding of soils, and it's a great place to start. You still have to do on-site investigations most of the time, but this is a great tool to head you in the right direction. And we'll talk more about this out in the afternoon session. I want to start out with a typical soil profile. And I realize some of this will maybe just be refreshers for you. Maybe sometimes some folks this will be the first experience. Typically, we have topsoil, subsoil, parent material. Sometimes that's referred to as A horizon, B horizon, C horizon. And during my talk, if I use the word A horizon or topsoil, hopefully you'll know what we're talking about. But the topsoil is that friable, rich material at the surface that's went through a lot of the soil forming processes, has organic matter in it, and that's what we want to preserve to grow our crops in, particularly. Then the subsoil is typically more clayey, less organic matter, and is not, oftentimes not a very desirable place for crop growth. So you want to be careful, about skimming off that topsoil and working the subsoil. And then at the bottom we have the parent material. That's what the soil is forming from. It could be glacial till, it could be what we call outwash, it could be less, a lot of things. Particularly here in central Indiana, our parent material is commonly glacial till. And we'll talk more about that, but if you scalp that soil off down to the glacial till, then you've got all kinds of problems relating to plant growth, water movement, etc. So anyway, a typical soil profile, now you're going to see all kinds of variations of this. But basically, almost all of our soils follow that pattern of an A horizon, or clayey subsoil, and then the unweathered material below. But there's literally thousands of variations that you're going to see. So let's start off with texture. One of the very important things we need to consider when we're considering soil use. And just want to briefly remind you that we have clay particles, silt particles, and then the sand particle. And this chart just gives you the size. Obviously the clays are very, very small, but are have lots of properties that influence the soil use. And then the silt is a slightly larger. Silt feels like talcum powder to me. In fact, I think it's the same size material. And remember, this is all based on size. And then we come to the sand fraction, and we have 5 sand classes. And I think it's terribly important to remember, if somebody says, well, it's a sandy soil, there's such a difference between a sandy soil that's high in very fine sand and a sandy soil that's high in very coarse sand. The permeability would just be, tremendous difference between the very fine sand and the very coarse sand. Now, fortunately, here in Indiana, here in central Indiana, we don't have many sandy soils, and so that's not a big issue, but there are places like in Bartholomew County, Morgan County, where we have the sand, and particularly northwestern Indiana have a lot of sand there. And the sand size becomes very critical when you're planting practices, whether it's dominated by the fine sands or the coarse sands. And then something else to consider is the particles that are larger than 2 millimeters. We call that gravel or chert, etc. And again, we're blessed here in central Indiana not to have too many soils with a lot of gravel in it. You go some parts of the world, the northeastern U.S., loaded with rock fragments. But we do recognize those, and so when we come to the particles that are larger than 2 millimeters, we might define a soil as let's say it's a clay loam, but because it has a lot of gravel in it, we call it a gravelly clay loam. And you would certainly notice the difference between a clay loam and a gravelly clay loam if you're out there digging with a shovel trying to maybe set out some plants, because if it's high in gravel, it's going to be difficult to dig in on this. So that's our basic outline for texture: sand, silt, and clay. And then we also want to remember what we call coarse fragments or rock fragments. And this is simply what's called the USD textural triangle. And it's quite a simple thing to use. The hard part is determining what the silt content and the sand content and the clay content is. But For instance, in my example, and the clay percentages goes horizontally, and the sand percentage runs vertically from the bottom right to the upper left, and then the silt runs at an angle down from the upper right toward the lower left, as I look at it. So, for instance, if you have 20% clay, 20% sand, and 60% silt, it would fall right in that category of a silt loam. And so this makes life easier for us to talk about when we talk about soils. You can say, well, it's a loam texture, it's a clay loam texture, and people involved in soils will know roughly what some of the properties will be based on that texture we assigned there. And this is rather primitive, but the way most soil scientists texture soils is with your fingers. You develop over a period of time kind of a feel for estimating clay. Obviously the clay feels sticky, the silt feels smooth, like I said, like talcum powder, and the sand feels gritty. And so you just wet down a sample and start to texture it in your fingers. And of course, you also will take lab samples to make sure you're doing it right. You know, you do it for, you texture something, you say, well, I think it's a silt loam. Fortunately, we had an STS we had access to the labs, we could send it to the lab, and then come back and it would verify whether we were right or not. So you begin to calibrate your fingers so that you can do a fairly good job. This is just a rough little sketch of how to do it. And just take, we'll probably do this separately, but just take for instance, just take a moist sample in your hand, and for instance, when you release your fingers, if it falls apart, it's a sand texture. If it hangs together, it's a loamy sand. And then you just go down, and this is kind of based on making a ribbon. If you can if you run it between your thumb and forefinger, and you get a ribbon to form, it's going to be toward the bottom. If it makes a ribbon less than an inch long, it falls out in this category. On the left, loam, silt loam, sandy loam. It makes a longer ribbon, sandy clay, loams, etc. And if it makes a ribbon longer than 2 inches, it's a sandy clay or silty clay. So, and obviously this is not highly technical, but it gives you a rough idea. And I would encourage folks, if you're working with you know, water movement in the soil, those kind of things, try this sometime and see if you can get a feel for it, because it might save you some grief if you're you know, dealing with a plant that can't tolerate real droughty conditions, and you find out this is a bunch of sand. You might want to reconsider planting. But anyway, just a feel method of determining texture, and we'll look more.